The next thing I'd like to do is I'd like to talk about graphs of trig functions where you have a translation, a reflection, a shift, a change in amplitude, or maybe a change to the quarter points. As an example, I'd like to look at a general realization of plain old sine of theta. What I've done is I've thrown in some constants, a, b, c, and d here. First of all, the value that's in front of the sign that's multiplied, that value of a, determines, number one, the amplitude. If that value of a is 5, then that would tell you that the highest that sine goes would be 5, and the lowest that sine would go would be -5. The other thing it tells you is if a is a negative number, less than 0, then it would tell you that sine is flipped over a center line. Now, we haven't talked about what a center line is, but we'll talk about that here in a little bit. So flipped over center line. All right. Now, at the end, I'd like to talk about what C does. C basically shifts your graph vertically. If C is positive, then you would be shifting the whole graph up. If C is negative, you would shift the whole graph down, and you would shift it consistent with the value of C. If C was 10, you'd shift the whole graph up 10 units. If C were -10, you would shift the whole graph down -10 units. So this would shift the graph vertically, and it's consistent with the sign on C. Now I teach this next part a little bit different from your text. The values of B and D, what I will say is I will say that that affects your quarter points. Sometimes when you change your quarter points, it also changes the period. Sometimes it does not. The book, what the book does is says that that value that's subtracted on the inside, D, that shifts your graph left and right. And then the B on the front either stretches or shrinks your graph. Okay, but I've found that it's more convenient just to consider anything that's with the angle. In other words, the B is multiplied with the angle on the outside, and the D is subtracted from the angle on the inside. Those things that are with the angle affect your quarter points. But I'm not going to worry about how they affect it. Here in a little bit, when I figure out quarter points, everything will naturally fall into place without me having to really think too hard. What I want to do is I want to think about the graph of 2 cosine of theta plus pi over 3, and then subtract off the 4 over one period. At the front of these kind of problems, when you are on a test or you're on a homework, I want you to make a note of the things that you know about this graph to begin with. Number 1, there's a value of 2 multiplied by the cosine. This will affect your amplitude. So the amplitude of this function would be 2. The highest I go would be 2 units above what we call a center line, and 2 units below what we call a center line. Okay, the second thing, we have a -4 over here. -4 is shifting the graph down 4 units. So graph is shifted down 4. Now what that does is it determines this thing we've been talking about called the center line. The center line is the line above and below that determines, or it's the line that above which and below which the amplitude is gained. So the center line is going to actually be at -4. And then because the amplitude is 2, we're going to go 2 units above -4, and we're going to go 2 units below -4. What is our normal center line for most basic trig functions? Well, it's 0. And so when I say an amplitude of 2, in that case, you know, it would be easy to say, well, it's +2 and -2. But anytime we have a vertical shift of some kind, that will affect our center line, and then thus that will affect our amplitude and where those high numbers and low numbers will be located. Now from here, I'd like to talk about what is happening with my quarter points. So I'm looking at the theta plus pi over 3. Alright, before we talk about quarter points, we need to determine basically where my graph is going to start and where my graph is going to stop. Normally, for cosine, we start and we stop at 0 and 2 pi. Well, the problem is we don't just have theta in this case. What we have is we have theta plus pi over 3. And so whatever is inside with your angle, or maybe even if you have a multiple of your angle, set that in between your normal first quarter point and your normal last quarter point. Now, if we solve this for theta, it will show us where our new first quarter point and last quarter points are. So if we solve this, we'll have to subtract off pi over 3 from each side. Okay, over here, I'll get negative pi over 3. In the middle, I have just theta. And then on the right-hand side, I have 2 pi minus pi over 3. There, I need a common denominator. I'll put 2 pi over 1. The common denominator would be 3. And so on that side, this is going to end up being 6 pi over 3 minus pi over 3, which would eventually end up with 5 pi over 3. All right. So what I end up with is I end up with my first quarter point being negative pi over 3, and my last quarter point ending up with 5 pi over 3. Whatever this first number is always my first quarter point, and whatever I end up with here is always my last quarter point. Now the next thing I need to do is determine if my period has changed. I know that normally the period of cosine is 2 pi, but moving these quarter points and adjusting the angle may have influenced the actual period. To determine the period, I always subtract the last quarter point minus the first quarter point. All right, the largest minus the smallest. So in this case, I would have 5 pi over 3 minus, be careful because the last quarter point is negative, so I'm subtracting a negative minus a negative. So this becomes 5 pi over 3 plus pi over 3, which is 6 pi over 3, and that reduces to 2 pi. So my period hasn't changed. In other words, the length of my interval is 2 pi. The next thing I want to do is I want to determine exactly what my quarter points are. Now it turns out that even though it says quarter points, there are actually 5 of them. You'll have a first, second, third, fourth, and fifth quarter point. Before I can determine those quarter points, I have to determine what we call increments. Increments is the distance between each quarter point. Okay, to determine increments, I always take 1/4 of my period. Okay, in this case, I would take 1/4 of 2 pi. 1/4 of 2 pi is 2 pi over 4, which reduces down to pi over 2. So the increments for this problem are pi over 2. That's the distance between my quarter points. Now, I'm ready to determine my quarter points. All right, for this, I always know what my very first quarter point is. I will call this quarter point 1. Quarter point 1 is determined by the leftmost number in the interval that I solved earlier. This was the interval that I solved earlier. My leftmost number is negative pi over 3. Now, to determine the next quarter point, I will take that quarter point, negative pi over 3, and I will add to it the increment, pi over 2. All right, now here I can see I need a common denominator. So I need to multiply by 2, and I need to multiply by 3. So this will reduce to negative 2 pi over 3 plus, negative 2 pi over 6 plus 3 pi over 6. Okay, adding those two together, I get pi over 6. So pi over 6 is my second quarter point. Quarter point number 3. I take the quarter point that I just got, pi over 6, and I add my increment. My increment was pi over 2. I see that I need to get a common denominator. That common denominator is 6, so I need to multiply the second fraction by 3 over 3. Okay, in this case, I'll have pi over 6 plus 3 pi over 6. If I add, this will become 4 pi over 6, and then I can reduce both of those by 2, so I'll have 2 pi over 3 as that next quarter point. Quarter point number 4. Now do be careful, you're thinking quarter points, so you're thinking that maybe this one should be the last one. It's not. There are 5 quarter points. Quarter point number 4, I take the quarter point that I just found, 2 pi over 3, and I add my increment, pi over 2. I need a common denominator. And so I end up here with 4 pi over 6 plus 3 pi over 6. That will reduce to 12 pi over 6, which is 2 pi. Okay, I'm sorry, that's not right. I multiplied. Let me go back and correct that. Okay, last I checked, 4 pi over 6 plus 3 pi over 6 was 7 pi over 6. There we go. That's my 4th quarter point. And then from here to find my last quarter point, I would do quarter point number 5. Now, let me point out that you already know what quarter point number 5 should be. Quarter point number 5 should be 5 pi over 3. How do we know that? That was the last number in my interval up here. Okay, last quarter point should be 5 pi over 3. Now, I'm going to go ahead and do the work for this quarter point, though. I don't want to assume that this last quarter point is going to be 5 pi over 3. I'm going to assume that to find this quarter point, I need to take the 7 pi over 6, and I need to add my increment of pi over 2. Okay, get a common denominator. And so here, I'll have 7 pi over 6 plus 3 pi over 6. That would reduce down to 10 pi over 6. All right. Reduce both of those by 2, and we have 5 pi over 3. Now, I'm going to celebrate a little bit. That is actually what I wanted to get there. What this tells me is when I actually compute the last quarter point, it tells me that I've done all the work up above correctly. If I did not get 5 pi over 3, then there'd be some kind of a problem. The last thing I'm going to do here is I'm actually going to go now and graph. Alright, when I'm graphing, the first thing I will consider is I will consider where my center line is. My center line actually ended up at -4. What I will do is I'll draw a dotted line through that. That's not an asymptote, that's just a line that will help me as far as reference numbers. Okay, now I will plot on my theta axis the quarter points. The quarter points were at negative pi over 3, pi over 6. Okay, and I believe that one was 2 pi over 3. Let's check. Yes. 2 pi over 3. And this one was at 7 pi over 6. And then the last one was at 5 pi over 3. Alright, from here, what we're going to make a note of is that we know our amplitude was 2. So we're going to go 2 units above my center line, and we're going to go 2 units below the center line and label those two values. 2 units above would be at -2, 2 units below would be at -6. From here, I'm graphing cosine. I know that the general shape of cosine starts above my center line at its amplitude. Normally the amplitude is 1, so I'd start at 1. Okay, in this case, at this first quarter point, I would start an amplitude amount above the center line at the first quarter point. So it would be at negative pi over 3 and -2. Okay, now be careful. This vertical axis is not a quarter point, so we don't want to plot any numbers there. From that -2, the graph of cosine goes back down to your center line. At the next quarter point, it goes down as far as the number of amplitude points, and then it goes back up to 0, and then it will go back up to the appropriate amplitude above your line. Connect those points, and you've got your graph. Okay, this concludes this example of graphing trig functions.